going to talk about tides, what they are and why they happen.
Okay.
You ever been to the beach when the water level is really high up? And then you come back the next day and the water level is way down low.
No.
What's going on? Where'd the water go?
Where'd the water go? It was here last night.
Well, the change in water level is totally normal. It's called tides. Isaac Newton figured this out a long time ago.
Hello?
And when the water level is high, it's called high tide.
High tide!
When the water level is low, it's called, you guessed it, low tide.
Where'd the water go?
Well, it all has to do with the sun and the moon and gravity.
Gravity.
It's gravity. Gravity holds us down. It holds everything down on the earth. It pulls us to the center of the planet.
Gravity? Gravity? Gravity?
But that's not the only gravity that's going on. The sun has gravity, and the moon has gravity too, and it pulls on us.
What?
And when the moon and the sun tug on our earth, nothing really much moves except for the water.
What?
So the pull of the moon and the pull of the sun cause the water on the earth's surface to slosh.
It sloshes?
The pull of the moon causes the water to sort of slosh towards it, and when that happens, it bulges. That bulge is high tide.
High tide.
And the parts that aren't bulging are low tide. It's all about gravity and inertia. Well, we know about gravity, but what's inertia? Inertia is when something is sitting still, it's going to stay that way
I'm not moving.
unless something makes it move. Inertia is also the idea that if an object is moving, it's going to keep moving unless something stops it. Something like friction or gravity or a rock. Gravity and inertia. What does that have to do with tides? Plenty. So here's the moon, here's the earth, this is the water on the earth, and here's the sun. The moon pulls on the earth, and the side facing the moon kind of wants to stay the same. It fights inertia, but this gravitational pull from the moon is just way too much, and it pulls the water towards it, making a bulge. But here's the thing, there isn't just one high tide a day, there's two, and it actually looks like this. There's a bulge on both sides. How does that happen? Inertia
I'm not moving.
and gravity.
Gravity.
Inertia wants to stay put. Gravity wants to pull. On the opposite side of the earth, that's also pulled towards the moon, but the inertia is greater there. And the second bulge has a lot to do with spinning, too. We're spinning.
We're spinning!
Yeah, we're spinning on our axis. That's what makes day and night, high tide and low tide. But there's even more spin going around, okay? The moon rotates around the earth, okay? And the whole shooting match rotates around the sun. That's a lot of spin. Makes for a lot of inertia.
Fascinating.
There's this cool experiment you can do with stuff around the house to see this second bulge inertia gravity thing in action. Sounds complicated? Not really. Try it. All you need is a cup, some string, and a hole punch, and some water. So, first thing you do is you take your cup and your hole punch, and you're going to punch 2 holes near the rim, opposite each other. Then you take your thread, your string, and you put it through the holes.
Okay.
Okay, once you have the string through the hole, you're going to tie a knot, but you need a triangle, just like that. So you're going to tie a knot at the top of the triangle, just like that. And then you're going to fill it about 3/4 of the way full of water. Just like that. You might want to do this outside. All right, so I got my water, I got my string, the knot is nice and tight, and watch this. So, if I'm the earth and I'm spinning around, I'm throwing quite a lot of force out, and the water's going to swing out. If we're lucky, we won't spill a drop. Gravity pulls everything down toward the center of the earth, right? So gravity's affecting the water. The water stays in the bottom of the cup. But then we start swinging it, boom, you got some inertia going. That water wants to keep going, in a straight line, but the bottom of the cup is holding it in place. See, the water's pushing against the bottom of the cup. That's inertia. The whole thing is called centrifugal force. Gravity and inertia.
Try it.
Wow, now let me show you. There's no trick.
Try it!
And check out my blog. You'll find the experiment we just did. Woohoo! And you'll find some others too. See you next time. This is Lynn Brunel for Tabletop Science.